I'm going to try to write a program that aims to cover the screen with virtual flies. So let's start by creating a project and giving that project a class to represent the fly. Let's call that fly. And I'm going to use a JDialog for the fly because JDialogs have some special styling that allows them to look somewhat like flies. I'll initialize that JDialog in the constructor of this class. And by default, JDialogs are not visible, so you have to call the setVisible method on that dialog and pass in an argument of true if you actually want to see it. Have the main method new up a fly. So we should see a JDialog on the screen. Awesome, we do. Didn't have any size to it, so let's give it some size by calling the setSize method that takes the width and the height in pixels. And I'll store the desired size in a static final variable. Don't want magic numbers in your code. Doing this makes your code more readable and maintainable in general. So now we should have a 400 by 400 dialog. Great. Next thing I want to do is remove that title and the frame from it. So call set undecorated on the dialog. This is that special styling I was talking about that makes the thing look more fly-like. There we go, so it's undecorated. Let's give it a background color. I don't like that default gray. So get the content pane of the dialog. And the content pane has a set background method that accepts a color. We'll also factor that color out so we can change it easily if we want. And these colors are defined in the color class. They're static members on it, all the usual ones that you would want. Make the fly black for now. So now we should have a black dialog. Great. And the last thing I want to do is make it always on top of other windows. So right now, if I give the IDE focus, you see it obfuscates the dialog. We don't want that. We want the dialog to always be on top, just like a fly would. Fortunately, the dialog class has a set undecorated method on it. Just give that an argument of true. And now this dialog will always be on top of other windows, even when they have focus. Why did that not work? Not undecorated, I'm so sorry. That's what we just used. Set always on top. Okay, let's try that. All right, now even if the IDE has focus, that dialog is still on top of it, which is the behavior that we want. All right, so now that the thing is styled how we want it to be styled, let's do some animation on it. So I'll make a run method. The run method will have an animation loop, so a loop that just runs forever. And each time through the loop, we will update the position of the fly, call the setLocation method on that dialog, and I'll create a new instance member to store the location of the fly called location. And initialize that in the constructor. Just two ints, one for the x coordinate, one for the y coordinate, which is how we're using it here. Set location wants the x coordinate and the y coordinate of the dialog. Of course, this isn't going to be an animation because we're not changing the location at all. So we should change the location if we actually want the thing to move. So I'll make a move method that'll do that. It will take the x coordinate and increase it by 1, and the y coordinate and increase it by 1, which will make the fly move in that diagonal line from the top left to the bottom right of the screen. We should call that move method each time through this loop. And final thing, pause for a little bit at the end of the loop to control the speed of the fly. And we'll just pause for 10 milliseconds for now. Remember to call the run method after we set up the fly. Awesome, so we got the fly moving from the top left to the bottom right. Not very complicated animation, so let's do something a little fancier. Let's pick a random point on the screen and have the fly fly to that. The first step in doing that is to actually get the screen's size. Store that in this screen size member. And dimension is just something that encapsulates a width and a height. And we can get the screen size from the toolkit class. First, we need to get an instance of the toolkit class. We can do that with this get default toolkit method. And then the toolkit has a get screen size method on it. And I'll give you the screen size. Now, if we want to get a random position on the screen, it's not hard to do. Return a new double, get a random number between 0 and 1, and multiply that by the width of the screen to get a random x coordinate. Get a random number between 0 and 1 and multiply that by the height of the screen to get a random y coordinate. And that will be a random point on the screen. We want to set the destination equal to a random point. So just get the destination, set it equal to a random position. And then to make sure that this is actually working how we want it to work, I'll output that destination to the screen. And it would be helpful if we actually create an instance member called destination. All right, so now if we run this, let's see, we should set that variable to set new destination. We should see a random point on the screen output to the console, which we do. It's a 1920 by 1080 screen, so yeah, that should be a random point on it. All right, so we have a random point on the screen. How do we actually get the fly to fly towards it? It's kind of tricky because right now we're just updating the x and y by some amount each time through the loop. How do we update those such that it's moving towards the destination? Well, we'll need to know the angle to the destination. Let's assume that we do. Angle to destination. Then it's not that hard. Take the amount that you want to move each time. I'll call that velocity. And for the x coordinate, multiply that by the cosine of that angle. And for the y coordinate, do the same thing, except multiply by the sine of that angle. And velocity is just going to store how many pixels in total, the total distance in pixels that we want the fly to move each time through the animation loop. Set that equal to 5 for now. All right, so remaining open problem, how do we get the angle to the destination? I don't want to clutter up the fly class with geometry logic, so I will create a geometry class to store the geometry logic, and it'll just have some static methods in it. So I'll create one called getAngle that will get the angle between 2 points. First thing we need to do is get the delta x between those 2 points and the delta y between those 2 points. And once we have that, we can just compute the inverse tangent of those two things, and that'll be the angle between those 2 points. Now, if I want to get the angle between the location and some point, I'll make a utility method to help us with that. Call it getAngle to point, just pass in the single point. And this will just delegate to the method we just wrote and pass in the location as the first argument. All right, so now we can actually set this equal to the angle between the location and the destination. All right, this is complaining because location is an array of ints and getAngle wants an array of doubles. We probably want location to be an array of doubles anyway, because with this new update logic, the x and y coordinates are not going to increase by integer amounts each time through the animation loop. So we'll have to change the initialization, and we'll have to change how we call setLocation, since setLocation wants 2 ints, since it's the location in pixels, which are represented by ints. We could just cast these 2 things to ints, but that'll take something like 1.9 and truncate it to 1, which could make the motion look a little bit rough. It's smoother to round those things first, so 1.9 goes to 2 instead of 1. All right, so now if we run this thing, hopefully we should see the fly towards the destination, which it seems to be doing. Let's see what happens when it gets there. Okay, maybe that's not the best example since that one was off the screen. Let's see if we get a closer one. Yeah, we should be able to see this one better. So it got there and it stopped, even though we didn't code in any logic to tell the thing to stop. If you look closely, you can see it's vibrating about the destination. And what's happening is it's overshooting the destination, then computing the angle to the destination. And now that angle is in the opposite direction that the last move was in, and it overshoots in that direction, recomputes the angle again, which is now in the opposite direction again, and it's just bouncing back and forth. So we should add some logic to detect when we get to the destination. Put that in a method called check reached destination. And this is kind of tricky because the destination is a double, and doubles are pretty precise, and the motion of the fly, it's increasing its distance by 5 each time, so it probably won't precisely hit a destination. So we need to have some fuzziness in our logic here. The fly isn't going to reach the destination exactly, so we have to learn how to accept close enough. To do that, we need another geometry method to compute the distance between 2 points. Basically be the same as the get angle method. Get distance, and instead of the inverse tangent, just get the hypotenuse. And like we have the get angle to point helper, I want a get distance to point helper that will get the distance from the location to the point that you pass in here. All right, so to check if we've reached the destination, let's get the distance from the location to the destination. And if that's within some threshold, call it close tolerance, we will consider ourselves at the destination. I think 10 is a good conservative value here since we only increase by a distance of 5 each time. We should get within a distance of 10 of the destination. And once we get to the destination, set a new destination. And we'll fly to that one. All right, so now we should see the fly hitting a random destination, and when it does, picking a new one. We're not seeing that because we're not actually calling this method from anywhere. We should call this method at the end of the move method. So anytime we update the position of the fly, see if the fly is now at the destination. There we go, that's behaving much better. So the fly is now flying in a straight line from random point to random point. Can make it look a little better by making the fly smaller. Make it 1/10 of the size. It looks a little more like a fly. I would make it smaller, but then I'm afraid it wouldn't show up in the video. Okay, so this looks pretty good. My only qualm with this is that the fly is too focused. It's flying in a straight line from point to point. In my experience, flies seem to meander about a little bit more than this. So I'm going to propose a new fly algorithm that tries to kind of capture that behavior. So what we'll do is we'll have the location like before. We'll still pick a random point on the screen for the destination. But instead of flying in a straight line from location to destination, we'll draw a circle around that line, pick a random point in that circle, fly to that point in a straight line, and then repeat the process. So draw a straight line from new place to destination, and draw a circle, pick a random point inside that circle, and fly in a straight line there. We'll call this random point inside the circle the sub-destination, by the way, and repeat this process until we get close enough to the destination. So what this does is globally, the fly still has an objective, the destination, but locally it meanders about from point to point. So hopefully that will look more fly-like. So let's go ahead and implement that. We'll need a new instance member to store the sub-destination. And we'll need to initialize that variable and then set it equal to a sub-destination. So make a new set sub-destination method. And to set the sub-destination, we need to know where the center of that circle is. So let's pretend for now it's at the location of the fly. And it's not, it's actually, we want to start at the location of the fly and move an amount equal to the radius of that circle towards the destination. That will actually be the center of the circle. And so that's going to be very similar to the move logic that we have because we want to move towards the destination a given amount. instead of moving an amount of velocity, we want to move an amount sub destination radius. I'll set this equal to 75 for now. So take the location and add to it the amount that we want to move, sub destination radius, and multiply that by the cosine of the angle to the destination for the x coordinate, and for the y coordinate, do the same thing, except instead of the cosine, we want it to be the sine. And we should initialize this angle to destination variable. All right, so just like the move method. So now that we have the center of the circle, we want to get a random point in the circle. So the way to do that is to choose a random distance that we want to move from the center of the circle. So get a random number between 0 and 1, multiply it by the radius of the circle, so destination radius. And then to get, still did not spell this right. And then to get a random direction to move in, get a random number between 0 and 1 and multiply it by 2 pi. So now we have a random distance that we want to move from the center of the circle and a random direction to move in. So we'll set the sub destination equal to, start at the center of the circle, move an amount, random radius, in a direction, random angle. Same thing for the y coordinate, except instead of the cosine, we want the sine. All right, only catch is when we get close enough to the destination that falls within the circle. So that would be the case if the distance to the destination is less than the diameter of the circle. If that's the case, just set the sub-destination equal to the destination. All right, so now we have the complete logic for setting the sub-destination. Now we should actually fly towards it instead of the destination. So let's do that. Instead of flying to the destination, fly to the sub-destination. Okay, and instead of checking to see if we've reached the destination, let's check to see if we've reached the sub-destination. And when we have, instead of setting a new destination, set a new sub-destination. Only a new case we need to consider is if the sub-destination is equal to the destination, we also need to pick a new destination. All right, so this should be the new fly logic. We should have a global objective in mind, but kind of make random choices on the way to it, which seems to be happening. There we go. We just hit the destination, the first destination, second destination, and you can see that even though we've only gone through 4 destinations, the fly hasn't been going in straight lines to them. It's kind of been wandering about that straight line. Awesome. So the single fly logic is looking pretty good. The last thing we want to do is just make more flies. So make a new class called flies that's just going to create many flies. So let's do the straightforward thing. Let's have a loop. We'll go through this loop 20 times, and each time through, new up a new fly. And we only end up with a single fly. And the reason is not that surprising. If we go to the constructor, at the bottom we call the run method, and the run method has an infinite loop. So it never returns. So the constructor never returns. So line 6 never returns, and we never do the second iteration of this loop. So the problem is that this run method is blocking the main thread. We actually want the animation loop to run in its own thread so the fly can be moving about, but we can still do other work within the program. So I'm going to make an inner class called fly thread. I want it to be an inner class because I still want access to the fly members, the fly member and the move member of the fly class. And this will implement the runnable interface, which allows us to create a thread from it. The runnable interface just defines a single method called run, and that's going to be the method that the thread calls. So now instead of calling run from the constructor, I'm going to create a new thread, give it the fly thread to run, and call start on it. So what that'll do is it'll create a new thread, and call the run method within that thread. Then the main thread won't be blocked by that animation loop. So now if we run this, we do have 20 flies come up on the screen. It's a little weird that they all start in the top left of the screen, so let's fix that. Instead of giving the location the default, let's give it a random position on the screen. Then all the flies won't start in the same spot. There we go, that looks much better. All right, last thing I want to do, instead of creating all the flies at once, I think it'd be more interesting if we start with a single fly and then have that fly reproduce until we reach the maximum number of flies. I do think it's a good idea to have a maximum number of flies, because if we do typical reproduction, then the number of flies will increase exponentially, which means your computer will get overwhelmed with flies pretty quickly if you don't cap off the number of them. So start off with a single fly. While the number of flies is less than that maximum, let's give each fly a chance to reproduce. So how do we do that? Generate a random number between 0 and 1, and then check if that is less than some birth probability. So that equal to 20% for now. If it is, then we'll make a new fly and increment the counter. So the way this is working is map.random generates a random number between 0 and 1 uniformly. So it has a 20% chance of being smaller than 0.2. So we have a 20% chance of this condition being true and creating a new fly. Like with animation loop, we'll want to sleep at the end of this so we don't create all the flies too quickly. So we'll sleep for the gestation period of the fly. And I'll set that equal to 1 second for now. All right, so every second we give every fly a 20% chance to reproduce until we've reached the maximum number of flies, which I've set to 20. So we run this, we start off with our single fly, it just gave birth. Now each of these two flies has a 20% chance of giving birth every second. Now these 4 do, and you can see why this would lead to exponential growth. So now we have a pretty nice fly program. Last thing to do is let's package it up. Let's say you want an executable that you can just double click to run this program. So go to export, select the runnable jar file within the Java folder. Select the class that contains the main method you want to run. Specify a destination for the executable. I'll just drop it on the desktop, click finish. So now I have this flies.jar file, and if I double click this, it'll run the program for me. An interesting thing about using JDialog is that this program will not create a taskbar entry for this program, which means it's kind of hard to figure out how to close it, which makes it a good program to send to people if you're a bit of a prankster. So to actually terminate the program, you'll have to open up the task manager and find the Java process and terminate that process, and that'll terminate the program for you. And that's it. That's the fly program.